Hey everybody, how you doing? This is it. This is the last lesson for the year for Algebra 2. I had wanted to get in one more after this, but I'm not going to push it. This will be Wednesday. This will give you 2 days to complete the last assignment and get it back to me, and I think that's fine. The one thing we're not going to touch on is something called radians. And I'm sorry we didn't get to it, but you'll get to it next year. It's another way of measuring an angle. But right now we're going to concentrate on degrees and how this fits into something that we call the unit circle. So, remember this triangle here? We were doing it the other day. Remember the special relationships? Now this doesn't say it, but this is a right angle. So this is the short side. We said the short side was 1. The hypotenuse was twice as long. And this 60-degree side, or the longer leg, would be the short leg times the square root of 3. That was the relationship among these 3 sides of this particular right triangle. Now I'm going to ask you this question. The unit circle is called a unit circle because we want the radius to be 1. So let me say this right now. Here I have a little quarter circle right here. I'm going to say, what's that point? Now that point I'm going to call 1, 0. Right, which means what's this point up here? Remember, this is a circle, so it'd be the same distance. It would be a 0, 1. Okay, so what if I took this triangle and I shrunk it so that this hypotenuse actually equaled 1? Kind of like this. So this distance is 1. So it's half. So if I take half the hypotenuse, what do? I take half of everything. So this is 1. This was 1, and half of that becomes 1/2. And half of square root of 3 is square root of 3 over 2. Now I want you to think about this. Does that make sense? Remember what we said the sine of 30 degree was? Okay, if you remember, it was 1/2. Look on here. It's the opposite side, which is 1/2. Divided by the hypotenuse, which is 1, conveniently. So the sine is 1/2. The same would go with the cosine. Now I'm asking you, what's this coordinate point? What's the x and the y value of this point? So the x value is how far it is from here to here, which is square root of 3 over 2. And the y value is 1/2. So here's what I want you to notice about the unit circle. If I wanted to know the sine of 30 degrees, I just have to look for that. The sine of 30 is the second coordinate point. The sine of 30 is 1/2. And guess what the cosine of 30 is? Square root of 3 over 2. That's how we know the sines and the cosines. Okay? That is the trick of this unit circle. That the x-coordinate is the cosine of an angle, and the y-coordinate is the sine. All right. Let's continue this on and see if we can start seeing some patterns and making more relationships. I had this 45, 45, 90 triangle. The relationship was, if this side was 1 and this side was 1, then this long side would be 1 times the square root of 2. Okay. Well, I don't want that to be the square root of 2. Just like the other triangle, I want this to equal 1. So in order to make this side equal to 1, what do I have to do with this square root of 2? I divide it by the square root of 2, because square root of 2 divided by square root of 2 equals 1. So I'm going to do that to both sides. Move this down a little bit. Now, we don't want 1 over the square root of 2, because we learned before that we want radicals in the denominator. So how do I eliminate that root of 2 on the bottom? I multiply by the root of 2 over the root of 2. 1 times the square root of 2 is the square root of 2. Square root of 2 times the square root of 2 is 2. So this distance, let me put this back up here, from here to here is square root of 2 over 2. This distance is the square root of 2 over 2, which means what's this point right here? The x distance is square root of 2 over 2. The y distance is square root of 2 over 2. And remember, it's cosine sine. So what's the cosine of 45 degrees? Square root of 2 over 2. What's the sine of 45 degrees? Square root of 2 over 2. You don't have to do anything, any memorization. You just look at this unit circle and you can read it like a chart. All right? Okay, if you're with me still, good, because it's the same thing over and over again. Here's my 60-degree angle. So what did we say this was? We said that, again, this was the short side, which meant the hypotenuse was twice as big, and this long side was the square root of 3. But you know what we're going to do. I don't want that to equal 2. I want to fit that here. To go from here to here, it has to be a distance of 1. Because remember, every distance on this circle from the center out is 1. So in order to get from 2 to 1, I had to divide by 2. I'm going to divide everything by 2. So this is the square root of 3 over 2. This is 1 over 2. So what's this point? How far over? 1/2. How far up? Square root of 3 over 2. That's what you need to see, and we can fill out the rest. So I'm going to flash through these. All right. So look at this circle. 30 degree was square root of 3 over 2, 1/2. 45 was square root of 2 over 2, square root of 2 over 2. And 60 was 1/2 and square root of 3 over 2. So if you see a pattern, here it is. I'm going to write it. All right, remember this one? That was the square root of 2 over 2. Now, there's 2 more points on here that are pretty easy to see. Well, it's over 1 and up 0, so it's 1, 0. And this point here on the y-axis is 0, 1. Now degrees. You know the degrees from here to here was 30 degrees. From here to here was 45 degrees. From here to here was 60 degrees. And straight up is 90 degrees. And if you don't go anywhere at all, it's 0 degrees. So right here you have a little chart. Because remember, the cosine is the x value, the sine is the y value. So if I asked you, what's the cosine of 30? You look at 30 degrees, you look at the first number, square root of 3 over 2. What's the cosine of 60? Look at 60, it's the first number, 1/2. If I ask you the sine of 45, well, can't go wrong, they're both the same, but sine's the second number, square root of 2 over 2. What's the sine of 0? Oh, it's the second number, it's 0. The sine of 90. Oh, it's the second number, it's 1. So just by knowing this little chart here, you have those values at your fingertips. And there's a pattern. And I want you to see this pattern. Look at these first numbers. I go 1, square root of 3, square root of 2, 1. Doesn't seem like there's a pattern, does it? So here's 0. Going down this way. Here's 1/2. Here's the square root of 2 over 2. Here's the square root of 3 over 2. And all the way at the bottom here, we have 1. Not much of a pattern there. We see a little bit of a pattern. You see 1, 2, 3. Oh, but that's not a square root. Well, what if I made that the square root of 1? Would that still work? if I follow that pattern, square root of 1, square root of 2, square root of 3, square root of 4 over 2, which is 1. If I go up, square root of 0 over 2, it's 0. So it does have a pattern. That's how the pattern works. But if you just kind of look, 0, 1, square root of 2, square root of 3, and technically the square root of 4, all over 2. I'm going to give you a link to a video that shows you how to do this by using your hand. Okay, it's not so easy for me to explain it because I don't have a good perspective with the camera. But I'm going to show you. I'll send you a link to one. And you can see a little pattern there as well. Because what I want to do is extrapolate this now and take it to the second quadrant. So if you have a 30-degree angle that's right here, and we already did the calculation, so we don't have to do it again, this would be the square root of 3 over 2, 1/2. So what if I went on the other side, same triangle, but I flipped it over the y-axis? Okay. What's this point here? Or it's just a coordinate point in the second quadrant. So the x values are negative. I went to the left, square root of 3 over 2, and up 1/2. So there's that little pattern there. Now what's this angle? Remember, I always start from here and I turn out. I know that that's 30. But what is it all the way to here? Well, what's a full half circle? It's 180. But I didn't quite make it. I stopped at 30. I had 30 to go. So this angle is actually 150 degrees. From here all the way out to here, it's 150 degrees. All right, can you kind of see where we're going to go with this? Here's the 45, 45, 90 triangle. Okay, again, we know that this is square root of 2 over 2, square root of 2 over 2. So if I rotate that, reflect it around the y-axis, I have a point over here, which is exactly level with this point, which means I change one thing. All right, and then how many degrees is that? Well, what's 180 minus 45? So if I asked you, what's the sine of 135? You would say square root of 2 over 2. Because sine is the y value. If I said, what's the cosine of 135? You would say negative square root of 2 over 2. That's the pattern. That's the pattern. Now, can we put all this together in all 4 quadrants and all of these angles? Let's do the angles first. Now I'm going to have to write a little tiny on this one, and that's okay. So this is going to be 30 degrees. This is 45 degrees. This is 60 degrees. That's 90 degrees. Remember, that was 0 degrees. All right, what if I continue on? This is 30 more. Just so you know, there's always 30 in these segments of blue and black, okay? It's always 30. The reds are a little different, but, you know, it's okay. They're all kind of the same. So this is 120. It's 30 more. 30 more is 150. 30 more is 180. 30 more. 30 more. That's supposed to be 240. The writing is so tiny it couldn't even see it. There we go, 240. 30 more. 30 more. 30 more. If you get 30 more, you get 360. Wasn't 360 one full revolution of the circle? So you're back to where you started from. Now these lines in red are all 45. So 45 and 45 is 90. 45 more is 135. So you can think of it that way, as always in jumps of 45, or realize how far is it between these two. That's only 15. It's only 15. So could I just add 215 and say that that's 225? Right? And 15 more is 240. 300 plus 15 is 315. So these are all part of the special right triangles. All of these are created by triangles and trigonometry. Okay, let's put the ones that we know. We know that this is the square root of 3 over 2 and 1/2. If we know 30, which ones do we also know? Now I'm going to give you a little visual reference here. I'm going to make this rectangle. What four angles are hit by these rectangles? 30, 150, 210, 330. Why is that important? What does it help us do? Okay. With these rectangles, we know it's a vertical distance and a horizontal distance. So we have horizontal distance, vertical distance. That means we know this point. Because if this is square root of 3 over 2 1/2, this is negative square root of 3 over 2 1/2. What is it down here in the third quadrant? Well, in the third quadrant, guess what? Everything's negative. It's negative square root of 3 over 2, negative 1/2. Follow it over here to 330. Fourth quadrant, the x is positive, but the y is negative. We go down 1/2. We figured out those four from that rectangle. Now let's use a different rectangle. Let's use a rectangle for the 45s. Notice that's a square even. Alright, we know this point here, the square root of 2 over 2, square root of 2 over 2. What is it over here? Negative root 2 over 2, positive root 2 over 2. Remember, the x is negative, the y is positive. What about dropping it straight down? Third quadrant, they're both negative. And bring it on over here. So the x is positive and the y is negative. Positive, negative. What do you think? It is all almost 2 perfectly symmetrical. Alright, let's do the 60s now. So we got these four angles. Well, we already calculated this one, and here's the pattern. It's 3, 2, this would be 1. It's actually the reverse of this one. Alright, over here that means x value becomes negative, y value becomes square root of 3 over 2. It stays, I should say. Drop it straight down. They're both negative. Negative 1/2, negative root 3 over 2. Bring it over here. The x is positive. The y is negative. And we are almost done. We kind of missed four rather, I'm not going to say simple, but obvious ones. We didn't do these. All right, so you know these four right here. This is 1, 0. This is 0, 1. This is negative 1, 0. And this would be 0, negative 1. Oh, that's ugly. Let me try that again. Try it one more time. 0, negative 1. There we go. All right, so you know from what we talked about, the x value is cosine, the y value is sine. So for any of these angles, I could say, what's the sine of 270? So you look at 270. Sine is the second number. It's negative 1. What's the cosine of 135? So you look at 135. The cosine is the first number. Negative root 2 over 2. Okay, what's the sine of 60? We did that before. We'll do it again. Sine of 60. 60 is here. Sine's the second number. It's root 3 over 2. Now, we always put the sines and cosines on the unit circle. We never put the tangents. But what I'm going to ask you to do is calculate all the tangents. Remember, tangent is sine divided by cosine. So I'll give you a little hint. What's the tangent of 45? What's square root of 2 over 2 divided by the square root of 2 over 2? What's any number divided by itself? It's 1. Alright, so I'm going to put the tangents in red. I'm not going to do them all for you. I'm going to have you fill these out as well. Alright, sine over cosine. What's the square root of 3 over 2 over 1/2? Well, it's the square root of 3. Now, if you remember from the lesson we did the other day, this is what the tangents equaled. So with that in mind, can you figure out the tangents in the other 3 quadrants? And I will give you a little trick. Remember, it's sine divided by cosine, so the tangent is 0. Here, it's 1 divided by 0. The tangent doesn't exist. We say the tangent is undefined here. So if you know these values in the first quadrant, can you extrapolate those to the other 3 quadrants? So here is going to be your final project assignment for me. All right. I am going to give you one of these that's blank, and I'm going to ask you to fill it in. Now, you can fill it any way you want. You could look it up online, fill them in. You could look on here, fill them in. I don't necessarily need you to have them memorized, but I want you to write them out so that I know that you've got them, and I want you to keep it. I want you to use that next year when you take pre-calc. Now, how do I know you did it? You're going to take a picture of it for me and send it to me. And if you want to make it fun, make it colorful. Take a picture outside with you in your unit circle. Just give me a picture of it so I know that you completed it. And if you don't like the one I send you, make your own up. Okay? So I want you to see what you can absorb in this. I want you to realize you can find the cosines and sines of any special angle between 0 and 360 according to this pattern here, this unit circle. So thank you for listening. Thank you for all your hard work this year. I am going to be online Thursday if you have any last questions. And all I can say is it's been quite a year. So good luck to you guys, and let me know if you have any questions, and I'll be in touch. Alrighty.